Hi everyone, welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be learning about how to solve inequalities. Let's get started. Alright, so the first thing I want to talk about is graphing inequalities on a number line. But before we do that, let's quickly talk about the difference between an equation and an inequality. And I've got the definitions written for you here. An equation is a number statement with an equal sign. For example, x plus 5 equals 12. We need to find the value of x, which we know is 7, to make this equation a true statement. Whereas in an inequality, that is a mathematical statement that can be unequal. For example, x plus 3 is greater than 7. Now, you've probably seen these signs, greater than and less than, probably since you first started doing math, but it's always good to review them. So I've got them for you here. This sign tells us that the number is greater than. So the way I always like to think about it is that where the part of the arrow that's larger, see how this part of the arrow is larger, this is just a point. That just helps me understand that the larger part of the arrow is pointing to the greater number. So we've got greater than, less than, we've got greater than or equal to, and less than or equal to. Okay, now let's talk about graphing inequalities on a number line. We are going to be using open circles and closed circles. And let's take a look at what the difference of those two things are. An open circle, when we're graphing inequalities, shows that a value is not a solution for the inequality. And we use open circles when we're graphing greater than or less than. Now, if you are using a closed circle, we use closed circles to show that a value actually is a solution for the inequality. And we use closed circles when we're graphing greater than or equal to, and less than or equal to. And I'll show you an example of what I mean by that. Okay, so here's an example of an open circle. Our inequality says x is greater than 3. So see how this circle here is open. There's nothing, it's not filled in. That means that x cannot equal 3. It's anything above 3, but it cannot be 3. Okay, that's why the circle is open. Now in this inequality, x is greater than or equal to 0. You can see that the circle is closed because x could be 0. Okay, so closed circle if it is a solution. If 0 that tells us that 0 could be a solution for that variable. Okay. I also want to talk about recognizing equivalent inequalities. Now that sounds really tricky, but it's actually super simple. What I mean by equivalent inequalities is that the inequality can be written in two different ways. You may come across an inequality that's written like this. 4 is greater than or equal to x. And it's really simple just to switch it around as long as you remember to switch the direction of the symbol as well. So you can rewrite the inequality so that the variable comes first because truly it just makes it easier to graph. So we have x is less than or equal to 4. Remember, when we have equal to, we use a closed circle. So that is how we would graph x is less than or equal to 4. Okay, we solve inequalities the same way we solve equations with one exception. So you will solve for your variable the same way that you would with an equation, but when we're dealing with inequalities, the only difference is this, and this is really important to remember. If you multiply or divide by a negative number, you need to switch the direction of the of the greater than or less than sign. Same thing with greater than or equal to or less than or equal to. You need to switch the direction of the sign if you multiply or divide with a negative number. So let me take a look. This one's actually going to be a positive number, so we don't have to worry about adding. So we don't have to worry about that yet. But keep that in mind for slides that are coming up. Okay. The problem says solve and graph n minus 4 is less than or equal to 3. We're just going to solve this inequality we're looking for n. How do we graph this? So n minus 4 is less than or equal to 3. We're going to add 4 to both sides of the inequality, and we get n is less than or equal to 7. It's graphed this way, and the circle is closed. Why? Because 7 could be the answer as well. It's a solution as well. Okay, negative 2n is less than 14. Now we're going to be looking at what it looks like when we divide by a negative number and how we have to switch that symbol. Question reads, negative 2n is less than 14. the first thing I need to do is isolate that variable, and how to do that is to divide both sides by -2. Now, my -2's cancel out, and I've left with n is less than 14 over -2. But because I am dividing by a negative number, I have got to switch that sign. The symbol has to go in the opposite direction. So now that makes sense. N is greater than -7. Okay? And there it is graphed. All right, here's a real-world problem that involves inequalities. Antonio is buying milk for a breakfast event. Each container of milk costs $3. At most, he can spend $12 on the milk. Write an inequality to represent C, the number of containers Antonio can buy. Could Antonio buy 4 containers? Explain. All right, so written out in inequality form, we would write this as C, or the number of containers he can buy, times 3, the cost of 1 container, at most $12. And so to write that, we want the 12 to be the most he can spend, so we're actually going to use the less than or equal to symbol here. So we have C times 3 is less than or equal to 12. Now we simply have to solve the inequality. And the way we would do that, C times 3, we can write that out as 3C is less than or equal to 12. We're going to divide both sides by 3, and our 3's cancel out. And we have C is less than or equal to 12 divided by 3, and C equals 4. So he could buy 4 containers of milk. All right, everyone, that just about wraps it up for this lesson. Thanks so much for joining us, and we'll see you next time. Bye-bye.